with some certainty that this Twitter person is the same as this Facebook person. And the computers can help with that point, absolutely. But always the goal, I mean, of course, the goal with the computer is to eventually give you a unique ID so that we don't have to keep doing that work. We don't have to keep guessing if it's the same person. So the trend that we're trying to get to is to eventually give unique IDs so that a computer can know for sure if it's the same person, and then it can do something useful like, for example, contact you once and not call you 3 different times. I've got a cute little story about that. There's a whole industry about data quality. And what the industry does is it tries to make sure that the same person does not appear 7 times in the database of companies, which happens a lot. You don't get it as much in Israel and Palestine, but if you live in America, you're getting constant mail, email, spam, junk mail, and often you're getting it 2 or 3 times. Anyway, so there was this conference which I went to on data quality, and of course I received 3 invitations to the conference. So Facebook is a company, it's a startup, it's now been bought 2 months ago, I think, by Google. Freebase, what did I say? Freebase is a startup which is now owned by Google, and they have done a job of taking mainly, what they've done is they've gone to Wikipedia, and where is it here? So they go to the Wikipedia page for Madonna. They do not have much natural language processing, so they don't really know what to do with this. But they can read this quite well. So they know Madonna, which films she's been in, you know, her name, her citizenship, date of birth, a lot of data like that. And they've taken that all into one big database, which has about 20 million objects or something. So Madonna has a unique ID, and she has relationships to films and music tracks, and you know, places and stuff like that. And Freebase have an open API which uses a standard called JSON, and it's one of the projects you may well want to consider using during the hackathon, because there's a lot of data about the real world in there, people, places, products, and all the attributes and relationships between them. And you can go to the site and navigate through the GUI, and then you can switch to the API. Now what I've done in my project, which is called the graph.net, is taken mostly the same data and put it into an object graph. And for some developers may prefer this because it's a much more familiar type of way of presenting data. And I have a Java API, so you can actually sort of do something a little bit like the pseudocode that I showed before. In Java, you can say, give me an object, give me a relationship, perform a search, perform a query. And just for fun, and this is something, again, some of you may want to do, I've added some voice synthesizing for that as well. So.
Abraham Lincoln, February 12, 1809 and hash 160, and hash 8211, April 15.
Okay. So, and again, that's actually quite easy to do. You know that there are APIs nowadays for doing voice synthesis, and that can be a fun thing to add to the site. An important project which I just came across recently is linked data. It's one of the, I think, what they're trying to do is bring together many different ontologies to Randy's point and link them with each other. And then under that, there's some specific areas like, for example, open commerce, which has a lot of information about products and shops and prices, and there you can see the Nikon camera, and you can see what different shops, what price they have, and you can see the specifications of the camera. So if this is an example of Freebase is cross-domain. This is an example of a specific domain, which is open data on the area of commerce. They've got apparently 2.6 different businesses, over 2 million businesses, over 2 million products. So to your point, you know, people are managing to get some big data sets together, and with modern computers that's not particularly difficult, and this is RDF based, so if you want to query this, you need to use Sparkle, which is the standard language for RDF queries. In the social world, there are several projects. There's a friend of a friend, which is trying to give people unique IDs, and then there's, I guess, competing, I think, in a way, Google have something called Social Graph API, which is also trying to find people through Twitter, through Facebook, and bring it all together. I'm not sure how successful they are yet. I haven't got a lot of experience. Facebook has something called Open Graph, which I've also integrated my project to, where a website has some hidden metadata to tell you the person it's about, to tell you the product that it's about. If it's about a book, you can put the ISBN number, and then it becomes, then you can have that like button, and then Facebook know that you like a website which is about Harry Potter or something. There's some geolocation stuff to do with location. You might want to look at OpenStreetMap, which is like an open source version, I guess, of Google Maps. You can go in and edit it and make sure that this hotel is there and stuff like that. And geonames. There's a whole list of sort of government data. This is the organization that we're affiliated to now, the Open Data Day, which other people are running, and they have a list on their wiki of different government data which has been made public. And I know in America there's a huge effort to put all the government data online, and they have a list of tools there as well. So I was going to stop now for 5 minutes and let Eitan say a few words about Semantinet, which is another relevant startup, which is represented here, and then I will carry on.
So I'm happy to be here. I'm from Semantinet. Sadly, our CDO couldn't come, but hopefully just as good. What we do, as I see it, we have two strengths. One of them is analyzing text. One of them is bringing world knowledge about this text. And the way this is combined is like you have layers in, when you look at a map application, let's say in Google Earth, you like have layers of data that come one on top of each other. And we try to do something similar to text, to articles, or to different kind of text that you can find on the web. And I want to present two APIs that we offer. Can be used, you're welcome to use them. For example, we have here a playground where you can test different kinds of text and see what happens. So if, for example, I take this default text, you can see that our technology analyzes the text and brings out entities that it finds there. If I look at Norway, you can see on the bottom that we point to the Norway, the country in Wikipedia, and same with George Clooney or the Netherlands.
I showed them the mouse over, that's cool. Just hover there for a second. You see it says type country, so it recognizes there may also be a, right, am I understanding it? There may also be a song called Norway, but it's recognizing from the context that this is the country, right?
Mm-hmm. This is one part of the technology, and the other part is the ability to bring world knowledge about these entities. So if I want to, say, bring all the movies that the actors in this text are playing in, I can query databases like Freebase and get a list of all the movies that the entities in these texts are playing. I can go through a couple of examples that I have here. We went to analyze, you see the Google site of this hackathon, and we got a list of entities that can be found in the website of this hackathon. I think you can see Vejala, and Zvi is in there because he's mentioned in Wikipedia. original site. I'll show you how it looks like. Simple text, and it got analyzed, and the relevant entities, the main entities, were brought from the API. Now I want to show how this data can also be manipulated. So what's done here, you see up there that there is a target URL in Jerusalem, in the Jerusalem Post. This is an article from the Jerusalem Post under their business section. And what's getting done here is the entities from this article are taken out. Then we look at all the companies in this article and take what industries these companies are in. You see smaller to industry, that means you order the API to find what industries these companies are working in, and then find other companies that also are in the same industry. So what we get here is list of competitors of the companies that are mentioned inside the article. These are examples of queries and data that use real world knowledge you can use to try to work on entities in the real world. You're welcome to check it out. We have links in the with the communication. Very easy to get here. And we offer, there's a rate limiting of 1 call per second, but other than that, free to use.
Thanks, Ethan. This is a very